Okay, now, um, the first question here, in question 7, speaks about complementary events. I want us to have a look at complementary events. Now, I have here that two events such that one will occur if the other does not occur. In other words, you can think of this as one event being outside the other event. For example, if you have a coin and your event there is a head, event 2 a tail. When a head when a head appears, a tail will not, and therefore those two events are said to be complementary. They cannot happen at the same time. One is outside the other one. Another example would be if you have a bag that contains 3 black balls and 2 yellow balls. If the first event is a black ball, you can't have a yellow ball. Or if the event is a yellow ball, you can't have a black ball. Now, let's go back to the probabilities then. The probability from the situation of a coin, we know that for a head, it's half, and for a tail is half. Take note of what happens when I add them. When I add the probabilities of these two events, let me write it properly here. Probability of E1 plus probability of E2. It is going to be given by half plus half give 1. Going back, take note that now we just said these two events are complementary. Even in this situation, okay, the probability of getting a black ball, it's 3 out of 5. The probability of getting a yellow ball, it's 2 out of 5 from there. Let's see what happens when you add the probabilities. These events are complementary. When we add their probabilities, we get 1. And that's the general case, that if events A and B are complementary, then the probabilities, the sum of their probabilities is 1. Which means if I know the probability of the other one, I can work out the probability of the other one by subtracting it from 1. So, how do you check that two events are complementary? If you add their two probabilities and you get 1, then you know that you can classify the events as complementary. Now, heading straight to 7.1.1, you were to complete the statement here that probability of A plus probability of B, you're supposed to have got 1 here. It is 1 since events A and B are complementary. Then 7.1.2, you were to write down the value of probability of A and B. Now, that probability is 0 because it is not going to happen. Remember what I said in the previous lesson. If the probability that an event can never happen, then we put it as 0. Why are we saying it is 0? Complementary events are mutually exclusive. In other words, they cannot happen at the same time. So you can't have probability of A and these two events, A and B, happening at the same time, it is 0. The probability of A and B is 0. So that's another mark. The other one is there. So for complementary events, the sum of their probabilities is 1. And the probability that both happen at the same time is equal to 0, because it can never happen since they are complementary. Then, just to illustrate that, I have a Venn diagram here showing set A and set B. These are totally mutually exclusive. They cannot happen at the same time. Why? There's no common outcome between them. In other words, there's no intersection between the two sets for event A and event B. And again, you should take note that the number of elements are in set A 2, in set B is 4. It's 1, 2 there, then 1, 2, 3, 4. And it should give you the total in the sample space, which is 6. So in the same way, the number of, if the sets are complementary, number of elements in A plus number of elements in B gives you the number of elements in the sample space. Then the next question, you were to write down the value of PB, probability of B. There's something that you should take note of. When this sign here in probability, when you have A dash like that, it means the complement of A. The complement of A. A dash means the complement of A. That is the set outside A. The outcomes that are outside A. And the question has just told you that A complement is the same as B. So A dash is the same event as B. So if you know the probability of A dash, it is going to be equal to the probability of B, because these are the same sets. If A and B are complementary, then the set outside, A complement, set outside of A is the set B. Then the probability of A complement, which is the same as probability of B, is given as 0.35. That's another mark. Now, getting into the question, that one about a survey, 150 learners, take note that in our Venn diagram, the number that comes outside the box here, the Venn diagram gives you the sample space, the total number in the sample space. Then you are given that, the question here gives you that 8 learners did not own either a smartphone or a tablet. So you shall put 8 outside the union of S and T, outside these sets here, because none of them own either a smartphone or a tablet. So I put the 8 here outside the two sets. Then it says that 20 learners own both. Both here means the intersection between set S and set T. So I'm going to have 20 in the intersection. They own both. Then 48 own a tablet. If 48 here owned the tablet, it means that the number who own both and who own only one type, which is a tablet, should be 48. So if I have 20 who have both, then it means I'll have to have 28 who only own tablets. 20 plus 28, 48. When you add these two entries here, you're supposed to get the total for the set. Then, X learners own smartphones. X smartphones, you're going to draw an arrow that goes to the set here, smartphones, then denote it as X. You are given that it's X. Now, if I have 20 in the intersection, then it means that here, those who own only smartphones is going to be the total here minus 20. So it's X minus 20 here. Okay, now that's your Venn diagram there. And when you've done it correctly, 1, 2, 3, 4, you're going to get 4 marks for that. Then the question 7.2.2, how many learners owned only a smartphone? How many learners owned only a smartphone? We are interested in this number here. Those who owned only smartphones. But now, I am going to say, okay, I know that the total number of learners is 150. So, where do I get that 150 from? The 150, you get it from adding the entry here, smartphones only, the intersection, and tablets only, and those who don't have any. So I am going to be having here X minus 20 plus 20 in the intersection plus 28 who own only the tablets, then 8 who don't own anything. When I add all those, I get 150. If you are to solve that equation, you'll get that X plus 36 minus 20 plus 20 plus 28 plus 8 gives me 36. So it's X plus 36 is equals to 150, giving me X as 114. So, but remember, the question wants you to find the entry here, which is X minus 20. You've just calculated that X is 114. So you take out 20 from 114 to give you 94. That's the answer. Then, next question. Calculate the probability that a learner selected at random from the group owned only a smartphone. Those who owned only a smartphone, you just said they are 94. Remember, probability of an event is equals to the number of the events divided by the total number in the sample space. So we're saying we have 94 who own smartphones only out of a sample space of 150, giving me 90 out of 150, which goes down to 0.63. That's your probability. Then, for the last question, those who owned at most one type of device. That word there, higher at most, it means that those who owned one or no phone at all. One or not any phone at all. So I'll take this one here, A, we just said 94, one only, and none. So what is it? It's 94 plus 28 plus 8 out of 150, giving me 130 over 150, 18 over 150 as the final answer. Yes. Now, that's that for this question here.